Hi everyone, so here's the notes for lesson 6. We're going to talk about how do we solve exponential equations. Okay, let's talk about what are the steps in order to do this. Okay, so what we need to do to make sure when we solve is get the bases to be the same. So notice here this property of equality for exponential equations. What this property really means is that as long as the bases are the same, so this b and b, as long as these are the same, what we can do is we can set their exponents equal to each other and then solve. Okay, so that's what it says here. So get bases to be the same and then set exponents equal to each other and solve. Now, this is actually going to be one way that we are going to solve exponential equations, because later on we're going to see, well, we cannot always get the bases to be the same, but we're going to practice this first. So make sure, pause this video if you need to get all of this information down, and then we're going to do our first example. Okay, let's go and look at our first example. So we're going to solve here. So here we're going to have, okay, here we go. Sorry, the other problems, they were not like your notes, so I just kind of changed it a little bit so they are now exactly like your notes. Okay, now let's go and look at example 1a. So we have 5 to the 6x minus 2 power equals 5 to the 20th. So notice here that our bases, which are 5s, they are exactly the same. So they are the same number. So because our bases here are the same, what we can do is set the exponents, which is 6x minus 2, and the 20, we can set those equal to each other. So now we have 6x minus 2 equals 20, and now we just solve for x. So we add 2, so we get 6x equals 22, divide by 6, and then make sure you do simplify your fraction here. We do want to keep our fraction as a fraction and not a decimal. So 22 over 6 becomes 11 thirds, and then that would be our answer. Now, if you need to check your answer, and this is not to check for extraneous solutions, this is just to check to make sure your answers are correct, we can plug 11 thirds back into x and make sure we get a true statement. Okay, so if we do, that means our answer is correct. If not, rethink your work. Okay, let's look at B. We have 3 to the 3x minus 2 equals 9 to the x. Now, not all our problems are going to be like example 1a, where our bases are already the same. Notice that our bases are not the same. We have the 3 and we have a 9. So because our bases are different, what we're going to have to do is get the bases to be the same. Now, in order to get the bases to be the same, we have to think about exponentials, not multiplication. So this is where it gets a little bit tricky, okay? So if I think about 3 and 9 and a number they have in common exponentially wise, the base can be 3. Now, just know when we are doing this, there are actually multiple ways to get to the same answer. Could we actually make the bases to be 9 on both of these? Actually, we could. We could do that, and we would still get the same answer, okay? But I'm going to make the bases 3 because it is a little bit easier to think, well, 3 to what power gives us 9, okay? Now, notice on the left-hand side, my base stayed exactly the same. So that means that my exponent will stay exactly the same as well. So 3x minus 2. On the other side, though, notice that I did change my 9 to a 3. Now, we can't just magically change numbers. The idea is that we're rewriting. We actually already did this when we worked on the inverse properties with our logs and exponentials. So that was in our lesson 3 notes, and that was like example 5. So we're actually doing something similar here. Now, to go from this, how I think about, well, 3 to what power gives us 9, that's going to be a squared. So the idea here is I'm just rewriting 9 as something else, okay? I'm not trying to simplify it. I'm not trying to like get rid of it. I'm just rewriting here. So 3 squared is another way of saying 9, okay? Now notice there is an x attached to the 9, so I do x next to the 2. We actually, once again, this is kind of very similar to what we did with our inverse properties with our logs and exponentials, and we had to kind of rewrite our bases here. Now that my bases are exactly the same, I can set the exponents equal to each other and solve. So I take 3x minus 2 equals to the 2x. And then I'm just going to move the 3x over. I get negative 2 equals negative x. Divide or multiply both sides by that negative 1. And so then I get x equals 2. And once again, we will not have any extraneous solutions here, but what you can do is take your 2, and if you want to plug it back into your x's and then see if you get a true statement, then that means you did the work correctly. If not, rethink your work, okay? Okay, I'm going to have you guys, let's try one more actually problem together. Let's look at 4 to the x equals 32. Now here, notice that on B, we just changed one of the bases, okay? Sometimes when we are doing these problems, we may have to change both of the bases, okay? So let's look here. We have 4 to the x equals 32. Now, of course, 4 and 32 are not the same. We got to get them to be exactly the same. So what we may have to do is actually change both of these to be the same basis. So we have to think about, well, 4 and 32, what's the number they have in common exponentially wise? Don't think multiplication. Well, the number they have in common exponentially wise is actually 2. So I'm going to have 2 equals 2. Now, once again, we can't just magically change the basis. We are rewriting, not trying to solve, not to simplify, we're rewriting. So I have to think, well, 2 to a power would mean the same thing as 4. Well, that's going to be 2. And notice that there is an x next to the 4, or as the exponent, so I do need to put it next to the 2. Same thing here. I'm not trying to take like the 5th root of 32 or trying to do 32 to the 1/5 or anything weird like that. I'm just rewriting. So I'm thinking 2 to a power gives me 32. That's going to be 5. I'm rewriting this as my 32. So now that the bases are exactly the same, I can set the exponents equal to each other. So 2x equals 5. This one's a little bit easier. Just divide both sides by 2, and I get x equals 5 halves. Or this one, because your decimal does terminate, you can write it as a decimal as 2.5. Okay, here's what I'm going to have you guys do. I'm going to have you guys pause the video and try examples D and E. Okay, let's see what you guys did. Now, I do want to let you know on D and E, there are actually multiple ways we can get to the same answer. Okay, that means like on D, when we're looking at this one, we once again will have to change both of the bases. Now, there could be another way where you just change one of them and have the bases to be 9. You would actually get the same answer. But I'm going to change them to be both 3s. So 3 squared, as stated, is another way of saying 9. And then I do have this 2x, so I'm going to multiply that. Going to change the 27 to a 3, but remember 3 cubed is another way of saying 27. And then I have this x minus 1. Now that my bases are exactly the same, I go ahead and multiply. So I have 2 times 2x, that gives me 4x. And I'm going to distribute this 3 to the x and minus 1. So I actually get 3x minus 3. Now solving, I move that 3x over, so I get x equals negative 3, and that's going to be my answer. Now, there is a possibility where you had your bases as 9. If you did that, you should get the same answer. Okay, let's look at E, because this is the same thing. You could do this and have different ways of solving and get to the same answer. Okay, so one way is we can make the bases to be 4 on both of these. We can make both of these to be the bases of 2. We can make them both as 1/2. Any of those ways that you did, you will get the same answer. Now, for my way, I made both of these to be 2's as the bases. And I'm going to show you another way where we would get the same answer. So if you made your bases 2, then you'll see this. So once again, I can't magically change 4 into 2. I think about 2 to what power gives me 4? That is a squared. And there is an x, so I'm going to have 2x. Same thing, I'm going to change my 1/2 to a 2. But I think, well, 2 to what power gives me 1/2? That's actually going to be negative 1, 2 to the negative first. Then I multiply that by negative, or x minus 3. Okay, now that my bases are the same, I go in and solve. So I have 2x equals, I'm going to distribute the -1. So I have negative x minus 3. Solving, I'm going to add x to the other side. So you have 3x equals -3. And then I'm going to go ahead and, oops, there should be a plus 3, excuse me. -1 times -3 gives me a plus 3. Then I'm going to go ahead and divide both sides by that. So I get x equals +1. Now let's look at it where we have, instead of doing 2 as a base, let's try something different here. Let's do it where we only change one of the bases. I'm going to do 1/2 as my base, okay? So I'm going to change this to 1/2. Now, once again, I can't just magically change 4 to the 1/2. So I got to think, well, since I'm going from a integer to a fraction, I'm going to have a negative exponent, similar to this option. And think about 2 to what power gives me 4? That's 2. So actually, I have -2x here. And that would give me that 4. Now, on this side, because I'm keeping the base the same, my x minus 3 stays the same. Now, the reason I'm showing you this method is to show you there are multiple ways to get to the same answer. So you may have made the bases 2, you may have made the bases 1/2, you may have made the bases 4, okay, you'll get the same answer. Now that my bases are exactly the same, I set my exponents equal to each other. So here I'm going to subtract x, so I get -3x equals -3. Divide both sides by that. Hey, notice we get the same answer. Okay. Okay, so that's how one way we solve exponentials, by getting the bases to be the same. Make sure you watch the next part because we're going to also still talk about solving exponentials, but when we have to use logarithms in order to solve.